Question 1, we have to use the definition of the derivative. So definition of the derivative f prime x, we have two definition. We have two different ways to write down the definition. It's a limit of t approaching x, ft minus fx over t minus x. Or you can also write it as the limit of h is approaching 0 at x plus h minus fx over h. Right. So you can use either of this to solve problem 1. Problem 1a. The derivative of 179 fx. Okay. So this, we call it a function gx. So it's just what's the derivative of, right? It's just what's the derivative of gx. So we can, let's use this. Okay, it's a limit of t approaching x, gt minus gx, right, over t minus x. So what is gt? gt is, right, 179 ft, right? What is gx? Gx is 179 fx, right, over t minus x. Right, for this constant, we can throw it out of the limit, right? So it's 179 limit t approaching x, ft minus fx over t minus x. Right, and what is this? This is exactly the definition of f prime x, right? So this is exactly the definition of f prime x. So this is 179 f prime x. Okay. Part B. What is the derivative of square root of fx? So again, square root of fx is called your gx now, right? So this whole function is called your gx. So it's the derivative of gx, which you can use the definition limit t is approaching x, gt minus gx over t minus x. Okay. And what is gt? gt is this part, right? Square root of ft. So it's square root of ft minus square root gx. Gx is square root of fx, right? Square root of fx over t minus x. Limit. Okay. Then how do we solve it? If here we remove the square root, right? This is the definition of f prime x minus, right? This is the definition of f prime x, right? So how to remove the square root? We can multiply the conjugate of the top. Can multiply the conjugate of the top. So here it's plus, right, over the bottom minus the conjugate of the top. Right, then now what is this top side? It's a plus b times a minus b. It is a squared minus b squared, right? So it's limit, right? Z square, it's ft, right? Minus z square, it's fx, right? Over t minus x, right? Times, okay, let me put it here. Square root of ft plus square root of fx. Okay. Then this part, this is exactly the definition of f prime x, right? And this part, we can do the substitution, right? Why? Because when you substitute t equals x, here it changes to fx, right? So So for this part, right, for this part, it is just the limit, this whole part. Okay, to make it clear, we can separate this limit. Okay, remember when you separate the limit into two parts, both limits must exist, right? So that you can separate. Otherwise, you can't separate. Right? So separate, it means the limit of the product equals the product of limit. Okay, now in this way, it's quite clear. This is f prime x, right? This is f prime x. And this part, you just have to do the substitution, right? T equals x. You use t equals x here. Right? You do the substitution. So this part is 1 over 2 square root of fx. Okay. So this is the result. And you can check the result, right? Because usually when you solve this derivative, you just straightly use the chain rule. Right? You try the chain rule. For the chain rule, okay, first it's square root of something, right? The derivative is half something, right, to the power of, right, half something to the power of negative half, right? So it's half this to the power of negative half, which is also half, right, 1 over square root of this. So it's half 1 over square root of this, right? Okay, then you ignore this, square root sign, right? Then it's just what is fx derivative. Fx derivative is just f prime x. So it's just this times f prime x. So if you use the chain rule, right, you should get the same result, right? You expect to get the same result because this is a definition, this is a chain rule, they should give you the same result. Actually, chain rule is derived from the definition, okay? So we first have definition, then we have chain rule, okay? So part C. Part C is quite similar. So part C, let me try. It asks you to prove d over dx 1 over fx. Right. So again, this 1 over fx, right, we call it gx. So it's just d over dx gx. So now let's try the other definition. It's limit h is approaching 0, g x plus h minus gx over h. So gx plus h, it's 1 over f x plus h, right? Gx plus h, you just sub x plus h here, right? You get 1 over x plus h minus gx, it's 1 over fx, right, over h. Okay, sorry, forgot the limit. Okay, so now you can calculate these two fractions results, right? You can calculate the difference. It is 1 over, it is fx, right, minus fx plus h over fx times fx plus h, right? And in the bottom you have an h, so times h, limit. Okay, so now this part looks like the definition of f prime x, right? This part looks like the definition of f prime x, but this should be before the negative sign, this should be after the negative sign, right? So here you want to exchange the position, so what you need to do, you have to put a negative sign in front, right? So it's negative limit fx plus h minus fx over h, right, times, right? So here I can separate the limit. Limit h is approaching 0, 1 over fx times fx plus h. Okay, so this part, it's the definition of f prime x, right? So it's just negative f prime x times this part, you just have to sub h equals 0 here, right? So this is, when this is 0, this part is just fx, right? So So it's 1 over 2 fx times fx, right? So it's fx squared. Okay. So overall, it's negative f prime x over fx squared. Okay. Again, you can use the chain rule. You should get the same result. 1 over fx. What's the derivative? When you use the chain rule, right? First, it's 1 over something. The derivative is the derivative is negative 1 over this thing square, right? So it's negative 1 over fx square. Okay, then you ignore this part, so it's just the bottom part. What is fx derivative? With fx derivative, it's just f prime x, right? So then you multiply them. It is a result. Okay, so the chain rule's result is same as the definition, the result derived from the definition. Right? Okay, so that's for problem 1.